You may have wondered how people end up making things like this or this. Many of these things are created with Grasshopper, and Grasshopper is a tool that people use to create parametric architecture and to just help them with advanced computation design. So in today's tutorial, I'm going to help you by getting started with Grasshopper, teaching you the skills that you need to help you learn Grasshopper in a better and smarter way. Welcome, my name is Reed, and if you are a beginner, you are in the perfect place. We will be taking it nice and slow today. We will begin by breaking down the interface and write our very first script. So grab a coffee, open up Rhino, and let's get started. We are going to start with opening Grasshopper by typing in Grasshopper in the commands and clicking enter. Wait for it to load. Now that we have entered, a new window pops up. Let's full screen this window and let's exit out of the getting started. As you can see, right now, there is currently no document open. The way that we can start a document is by putting in a simple component. We will go ahead and put in a point component just so that it can start. Up top, there's all of these different tabs. Now, I do have quite a few extra tabs, which are plugins that we can get from a website called Food for Rhino. I will go over plugins in a later video. Tabs that you should see are these: Math, Set, Vector, Curve, Surface, Mesh, Intersect, Transform, Display, and Rhino. Category has a list of components that are kind of part of the same family. It's a very well organized library that if you have trouble thinking of what type of component you want to use, you can click and figure out which of the components you want to use. And each of them has a definition on what that component will do. Up top, you'll have the various settings, including File, where you can create new documents, you can open documents, you can look at existing documents, you can save your document, you can export an image of your workflow, you can insert different clusters, which are files that you can find on the internet. You can look at the special folders that make up Grasshopper. You can change your preferences, and you can also close the current document. In Edit, you have things like undo, redo, cut, copy, paste, different paste options, delete. You can select all, deselect all. You can invert the selection, modify the selection. You can arrange them in certain ways, similar to moving things forward and back in a presentation. You can group items, ungroup items. You can also cluster them, which is what that cluster function was before. You can find an item. So if we type in point, it will highlight where that point is, and it also has an arrow that is pointing directly to that component. And the last is create. This is another way that we can search for components, and as you can see, a list of components pops up, and if we select one, it will then pop that component into place. And the way that Grasshopper works is essentially once you have an idea of what type of rules you want the program to do, you can then drag these wires from one to the other. The way that it works is from left to right, similar to reading, where it will read the point and notice that the point and the wire goes to the line component. And this next component is looking for a point. And once another point is placed in, it can then create a line. There is also warnings that you will get. The first is a yellow warning. It's more of a warning, but it will still be cautious and move forward with it. There is also a warning that is a red warning, which a red warning means that it has to stop in place. As you can see in this example, the main issue with a red warning is because it does not know how to read the previous wire into the next wire function. The next tab that we have is views. Views, these change how Grasshopper looks. We have a remote control panel, which is native to Rhino, which will set the display of the output of a Grasshopper script. We have ribbon, which these changes the ribbon from a word to an icon. I like to keep it as a word. There's canvas, which this canvas toolbar, if you end up using the canvas toolbar, you can keep it in there. There's also components tab, and components tab, it gets rid of all the components, as you can see. You also have panel separators, which these are these little lines that you'll see in here, which these are kind of the lines that kind of disappear. If we view those, it's more of a sub-organization of the panels itself. You have the obscure components, which these are the same components that are in the drop-down list, but now those obscure components are brought up to the top for you to see. You have a data viewer, which a data viewer, you can look at a certain data point and you can see what that data has in store. This is incredibly important if you have lists or trees. The next one is you can save the current view of your canvas, and then you can also go back to the current view. You can also zoom to the extents of the canvas, and then you can redraw the canvas to test the frames per second, and then you can also look at the info to debug. The next one is the display. This changes the display of the components in Grasshopper, and this also contains the display of what the output looks like in Rhino. These change different things within the canvas. As you can see, each of them doing something slightly different. The sunglasses is part of a plugin that you can get, and for me, I'm just using that to showcase both the name at the top and the icon for you. There is also the previews in Rhino, and currently I keep it on shaded preview. There's also previews of points, of planes, of meshes, and of gumballs. You also have these canvas widgets that pop up at certain things. So like these message balloons to see the warning. You can also see like the align tool where, say, this component is down further and you want to actually align these. You wouldn't be able to align them if you have it off. However, when you turn it on, you can see these align tools, and it's really helpful if you want to begin to organize your scripts. The next ones are essentially things like creating the solutions, running the computes, baking, which essentially is how you get your Grasshopper output into Rhino. You can also preview certain components or unpreview the component. And you can also enable the component to do its magic or disable it if you want to pause the magic for you to change the script. And then there's a help. If you ever get stuck, you can look at different support areas as well. So now that we have gone through most of the tabs, the last one that I want to go through is some of these Canvas widgets. You have things like opening up a Grasshopper file, saving, zooming, setting a named view or creating a view, making a sketch, changing what the output looks like in Rhino. And then also you have this nifty bar down here where if you type in certain components, it will suggest maybe another component that you'll want to just drag and drop. Okay, now that you know most of the tabs that are in Rhino, we're going to create a simple script. What I like to do is have it be at half screen for both of my items and then set it to a perspective view in Rhino. If you have two screens, this is perfect for you because you can drag Grasshopper into one screen and have it full screen and have Rhino full screen in another. We're going to start by trying to move in a box that is within Rhino over about 20 units. So to do this, we're going to first need to create a BREP, which these are found in the Parameters tab. The Parameters tab, it has these hexagonal shapes. These hexagonal shapes mean that it needs an input in order to start computing. What we can do is we can right-click this BREP and click Set One BREP. This is how we can then get something from Rhino into Grasshopper. Once I clicked Set One BREP, you'll notice that the BREP to reference command is popping up within Rhino. This can then allow me to click, and as you can see, it has turned green. And when I deselect, it turns red. Now that I have a BREP in Grasshopper, I can hide the BREP in Rhino. Once I've hidden the BREP, we can then start doing our computation to move the BREP within Grasshopper. So we can type in move. Move can also be found in the Transform tab. This Transform tab has various different types of transforms that you can do to a component within Rhino. For this one, we are using the box. If we put into the box, into the Geometry tab, we'll notice that the geometry has moved up. This is because it automatically has a motion set, which is moving the object in the Z direction 10 units. Now the units are based off of what your Rhino units are set in. My Rhino units are set in feet, but if your Rhino units are set in inches or meters or centimeters or millimeters, it will also do that. So I actually want to move it 20 units. So if I just double click and type in 20, you'll notice that a number slider pops up. Now if I want to do that and put in 20, notice how it turns red. This is because it doesn't understand that this number is wanting a direction value, which is a vector. So we can go into the vector column, and if we go to the vector tab, it can help us figure out which one that we might need. I'm going to select vector X, Y, Z. Once I change the 20 into vector X, we can then move that vector into the motion, and as you can see, the geometry has now moved 20 units. Now that we have made our first script, we can bake the geometry. When we right-click and click Bake, we get these different components, which changes how it will look within Rhino. I'm going to keep them as is and just select the default layer. When I click OK, we'll see that the component came over as a closed polysurface within Rhino. This is exactly what we wanted for our script, and it has completed every step that we have wanted. Now you may say, oh, Reed, I can do this already within Rhino. Well, this one is really neat because you can change it and see the value change automatically within Rhino. Let's also show the other box that we have put in. When we duplicate this box and we move them to different points, we can then highlight all of these boxes and right-click Brep. And then we can click Set Multiple Breps when we have all the boxes highlighted. Now, it has instantly changed every single box's movement 14 units, as this slider has said. As you can see in the geometry, there are 5 closed Breps. And in the transform, it explains what each object is doing. There's another way to look at this list. If we type in quotation marks, we can get a panel. And if we wire this into the panel, we can see the list of items that is being used. However, when we delete items from the list, we'll notice that it actually creates nulls, and it also creates a warning for the Brep. So a better way to do this is to actually use something called a geometry pipeline. This also has a hexagonal shape, meaning that it needs to come from another input. The geometry pipeline is asking for a layer name. If we type in default, we can then double click type. As you can see, all 3 of the boxes are highlighted. And when we easily copy them over, it automatically puts in all the new boxes that we needed. And when we drag the wire into the geometry, it does all of it instantly. It'll delete them, and it'll also do it to new boxes. This is a better and smarter way, and a better way to organize your Rhino scripts as well. Then we can bake all geometries at the same time in a new layer. And voila, you have made your first script. The last steps you'll probably want to do to this script is to organize it in a nice and orderly fashion so that you can reference the script and understand how each step is moving. Another way to make sure you understand it is by grouping different components based off of their movements and what they do. We can also create an overall group as well. And boom, you have just made a nice and organized script. And then we can go to the top and click Save Document and save it to a file within your computer. You can also export this as a high resolution image and set the background, and you'll get this, which no need to worry. And once you look into your files, you can see that a nice image with a clean background is ready to be put. Thank you again for coming to this beginner's guide tutorial, and I hope to see you around in the next video where we will go over points, vectors, and planes. If you learned something today, please like this video and subscribe to learn more in the future videos. Thank you.